Pleasant greetings to you all. Welcome back again, students, to yet another comprehensive review tutorial video from the AP3X Online Institute of Mathematics Education. My name is Akin, your math instructor. And of course, in today's video, we are going to be going through yet again another comprehensive review paper on a recently administered exam that I had designed for my students. Now, the questions that are structured on this paper are questions that I've extrapolated from older version of past papers that was administered by CXC years ago. So by compiling these questions, it will then give my students a realistic expectation of what is expected on the upcoming exam that is scheduled for May the 9th, 2025 at the time of making this video. Now, of course, we are about a month and a half out in terms of preparation. We have covered a lot, but we also have a lot still to be completed. So the aim and objective of this video is to give my students a sense of comfort, a sense of, correction, and improve the thought process and the critical thinking when it comes to these types of questions. So of course, if this is the first time you're scrolling by on my channel, I provide content that is strictly related to the exams administered by OEC on a yearly basis, both in January and also in May. I do majority of my lessons that are related to tough topics students find a challenge with, as well as review past paper questions. So if this is the first time here on the channel, do not forget to hit that subscribe button below. Leave a thumbs up if you got some value from my other videos or you're getting value from this video. Do not forget to hit that subscribe button. As I said, leave your thoughts and opinions in the comment section below, and any information in regards to getting access to my live classes, you will find all my contact information and social handles in the comments pinned below. So without further ado, let's dive right on in. Now, as you can see here, this particular paper is this is the end of month exam, one of 3 for this term, running from January through to April. And of course, I'll have more videos coming out as well. So this exam was administered, I believe, early in February, very early in February, and so I'm just getting the time to review this paper. So I'm hoping that at the end of this video, the students will have a clearer understanding of what they needed to do to get a good score on this paper here. So let's dive right on in. Now, as you can see from the instructions, very straightforward. It is to answer all questions as instructed, show all working where necessary to acquire full marks. And the institution, the physical institution that I work at is Manchester Institute of Learning, but I do have my own online platform as well. All right, so let's dive right on in. We're going to be here for a little bit over an hour and a half. So get your pens out, papers out, get a cup of coffee, get all the instruments needed, have your exam paper, which you would have done, and so you can apply the necessary corrections going forward then. All right, so here we go. Question number 1. So we are told that we have to evaluate 3 and 2 over 5 plus 1 and 2/7 in a pair of parentheses divided by 8 and 1/5. So we're just going to go ahead and pull up that on the screen here. And here is how we go about that question then. So first thing we want to do, ladies and gentlemen, when you get a fraction question, is you always want to ensure that all your mixed fractions are converted to an improper fraction. All right, and then of course we have to understand that when we're adding and subtracting is when we find the lowest common denominator, and when we're multiplying we're going to be canceling, and if you're dividing then we're going to be using the KCF method. So here we're going to go ahead and we're going to multiply the 5 by the 3, and we're going to get, say here, 15, and 15 plus 2, that's going to give us 17 over 5. And then we're going to add then 7 ones 7, and then we're gonna go ahead and add the 2 here. We're gonna get 9 over 7. All right, I'm going to proceed to continue converting all my mixed fractions to improper. So I'm going to have 5/8 is 40 plus 1 is 41 over 5. All right, so with that said, then, because this is in a bracket, we have to work out what is in the bracket first. So this would then require me to find the LCM, which in this case is going to be 35. And so we're going to go ahead and we're going to find out how many groups of 5 can we get from 35, which is going to simply give us 7 here. So it's going to give us 7 here. All right, and then we're going to have 7 into 35 goes 5 times. So if we go on our calculator, then 7 multiplied by 17 should give us an answer of 119. And then we're going to have 5 times 9 is 45. So we're going to end up then with a final answer on the left to be equal to 164 over 35. All right, that would have been the answer for the bracket section. Now we're going to proceed then to take this answer, and we're going to have 164 divided by 35, and we're going to divide that then by, see here, 41 over 5. Now once we are dividing, the rule is that we're going to use the KCF method, and the KCF method is where we keep the first fraction, which is obviously going to be 164 over 35, and we're going to change the sign from division to multiplication, and we're going to invert, or as we say, flip the last fraction. So some teachers will call it the KCI method or the KCR method, or as I call it, the KCF method. So it's keep, change, flip, keep, change, reciprocate, keep, change, invert. It just depends on what you're accustomed to or what you're familiar with. So I'm going to go ahead and I'm going to flip the 41 over 5, and I'm going to get 5 over 41. Now at this stage here, you can proceed to go ahead and multiply 164 times 5, and then we can also multiply 35 by 41, but then it would have been incomplete. And so I believe that all fractions should be reduced to its lowest term where possible. So in this case, we can look carefully that 5 will actually go into itself 1 time, and 5 into 35 will go 7 times. Now there are going to be cases where your timetable, depending on your level, your skill level in math, your timetable is going to be tested. So not a lot of persons are going to immediately know that 41 is exactly divisible into 164. So it doesn't hurt if you take your calculator and you pull up 164 and divide by 41 to verify if it goes into it exactly, and it does. It goes exactly into 164 4 times. So we can go ahead and cross that 41 out, put 1 here, cross that 164 and put 4 here, and so your final answer then will work out to be 4 over 7, and this is your final answer for the fraction. Oops, oh, got a big circle here. All right, okay, we're going to put that here. Give me a sec. Alright, so that's our final answer of 4 over 7. Alright, so that's how you want to approach your fraction problems, guys, when you get that chance. Let's move right along then to example part B of the question. Now we end up here having to evaluate the cube root of 13.31 plus 8.1 raised to the power of 2/3, all divided by 10 squared. And so once we have calculated the value of that, we are then going to correct our answer to 2 significant figures, to 2 decimal places, as well as to standard form. Now, when it comes to certain numbers, and when you're finding the root, depending on the root that you're trying to find, when it comes to certain numbers, you're gonna have to utilize the use of your calculator. Now I'm using a tablet calculator, so I have a very specific button for the cube root, but when you're using an actual calculator, you may need to press the shift button, and you may need to also press what I call the X cube button. Now notice here I'm gonna press this double arrow that is to my top left. That will open up another panel on my calculator. Now you can see here that I have a designated cube root button. But like I said, on your calculator, you may need to press the button that is to your top left. It is written on the button is written 2ND, or what is written on it is shift. So you would press shift or second function, and you'd press this X cube button right here that says invalid format, this X cube button that is blinking right here. Once you press shift and you press that X cube button, then it will pull up the cube root button here. So I'm going to go ahead and type 13.31, and then it's going to give me a value of 2.369. Now I kind of like working with 2 or 3 decimal places, so I'm gonna go ahead and just work with 3 decimal places here, 2.369. So I'm gonna go ahead and I'm gonna have 2.369 without rounding it off. That's not going to play a major error in my answer, so I don't have to necessarily round it off to 3 decimal places. I can work with 2.369. Now, surprisingly, while I was marking a few of my students' paper, it was quite shocking when quite a few students thought that this is 8.1 and 2/3. That's a little weird because this is not a fraction question. This is a decimal question. So there wouldn't be anything such as 8.1 and 2/3. That doesn't exist. So you can notice how small the number is here. Please ensure that you don't confuse a power with a fraction. All right, this is a decimal question, so there wouldn't be no fractions involved. Now, a few of my students have expressed to me over the months that I've been teaching them that sometimes they do find it challenging to enter that fraction on the calculator. So I'm about to show you how you can do that right now. So I'm going to pull up my calculator here. I'm going to clear my screen, and then I'm going to have 8.1. So what I'm going to do now is that I'm going to press the power button. Now on my tablet calculator here, my power button is this X to the Y here. This blinking button here is X to the Y. Correct. So that's my power button. Now notice the symbol that comes up on my screen. It is a arrow. Now some calculators have the X to the Y, some calculators have Y to the X, some calculators have like 2 empty boxes, or some calculators will have the button with this very arrow that you see here displaying on my screen. So you guys have to have your own personalized calculators and get accustomed to this button. This is called your power button, and it allows you to raise a number to any power, whether it be positive, negative, or it be an irrational number such as a negative or a positive fraction. Now, how do we insert 2/3 on the calculator? You can press 2 divided by 3 on the calculator. Ensure that you close the bracket. Now, be very mindful, ladies and gentlemen, that if in the event that you're not getting the 4.03 as instructed in the video, you may need to insert a bracket. Every calculator carries a bracket, so you cannot just type, for example here, if I clear the screen and I press 8, well, my calculator won't allow me to raise a number without the bracket, but there are some calculators when you press 8.1 and you press the power button, it doesn't automatically open a bracket. You have to be the one to open the bracket. So if you're using a phone, for example, to type this number in, then you may need to insert a bracket of, and then you insert 2 divided by 3 and close your bracket, and then we're going to get 4.033. all right, so I'm going to get 4.033, so that's going to be 4.033, 4.033, and divided by 10 squared is 100. Now, ladies and gentlemen, boys and girls, if you recognize that I'm emphasizing a lot on these critical things here, because these are the complaints that I get from my students yearly. There are students that are in my cohort group that literally has not, they have not really used the calculators a lot. So my video is, the aim and objective of my videos is to educate you thoroughly and holistically about all the little incremental mistakes that you guys make when you go on the exam. Of course, I could run through this paper within an hour and end the video, but then would you definitely understand the depth of what I'm saying? That's why I'm emphasizing so much on the critical thinking and teaching you what these functional buttons are on your calculator. All right, so let's continue then. So we're going to go ahead then and type, we're going to add the top here. So we're going to have 2.369. I already have this number written on the screen. So that's going to be plus 2.369. That's going to give me 6.402. I'm going to proceed right away to divide the answer then by 100. So divide by 100. I'm going to get 0.064. So the final answer for this then is going to be 0.064. And so this would be my answer exactly. That would be my answer exactly. Now, from that answer, I've already got my 3 marks here. Now, I need to take this number and I want to round it off to 2 significant figures. So, with 2 significant figures here, what I want to do is that I want to find the first 2 digits that's greater than 0. Now, be very mindful when it comes to significant figures, because 0 is usually considered to be an insignificant value, but it also depends on the position of where the 0 is. For example, in this case, these 2 zeros are insignificant because it appears before a non-zero digit, which is 6. Now, had one of those zeros been between the 6 and the 4, then we would have had to count the 0 as a significant digit. So in this case then, my first and second significant digits are 6 and 4. Now, if I draw the line here, I have to assume that the number that comes after is a 0. So therefore, 0 is less than 5, so there wouldn't be a change in the number. So basically then, the answer for this then would have been exactly what we have there, 0.064. There's no changes in the number. All right, and these things do happen occasionally on exams as well. Now, when it comes to decimal places now, is where now you're going to find that the 0 is going to play an important role, because it does hold a position. So in this case, my first 2 decimal places is going to be 0 and 6, because the 0 holds a place. I will then therefore go ahead and check the digit that comes after. Once again, in this case, we're looking at the number 4, which is also less than 5. So once again, then there won't be any changes in the digit before, because as we've seen it here, it's just going to be simply 0. Oops, I think I'm stuck. 0.06. That's going to be my answer here. All right, now in standard form then, this is now where we're going to be moving. This is where now we're allowed to move our decimal point to a specific location. Now, when it comes to standard form, we have to move the point to a specific location, and that location is dependent upon where the first non-zero digit is located. So in this case here, with a number like 0.064, the aim here is to move the point right between the 6 and the 4. So by doing that then, once I put the point right between the 6 and the 4, I'm going to create a new number, which is going to be 6.4. Now, some of you guys may wonder, why is it that you put the point there? Why didn't you put it in front of the 6? Why didn't you put it behind the 4? Why do you have to put it exactly between the 6 and the 4? It is because when a number is written in standard form, the base number should actually be greater than or equal to 1, but at the same time, it has to be less than 10. So in this case, anywhere I put that point apart from between the 6 and the 4 will either give me a value that is less than 1 or it's going to be greater than 10, and you can test it for yourself. So right where it is right now is exactly where we want it to be. Now with standard form, it's a base 10 number, so it's always going to be times 10. And so with standard form, it is raised to a power, so the 10 is raised to n, the power of n. Now n depends on two things. The power that we're going to write down is dependent upon the direction that we move the point, as well as the amount of places we move the point. So in this case, then we move 2 places to our right, and so standard form works in an opposite form of the number line. Now we naturally know that with the number line, going towards your right is positive, but because it's standard form and it's in reverse, then it's going to be negative. All right, so then the final answer then is 6.4 times 10 to the negative 2. All right, now a lot of the topics that I've gone through so far in the first 20 minutes of this video are topics that I would have taught my students way back in September. So, you know, if you didn't really master it, it might diffuse a little bit out of your brain, which you might find that this is why it's a little bit hard for you to remember. But these are fundamental things, and these are easy marks on the exam, so you don't want to miss out on a chance like that. All right, so we have brought ourselves through the first part of the question. Let's jump into working out this ratio problem here. Now when it comes to ratio, what we're looking at then is there are different ways how a ratio question can be structured, and as I said, in the upcoming videos that will be coming up in March and also in April, I'm going to expose you to a wide variety of questions that come in part 1A, part 1B, and part 1C. It's not always going to be a ratio question, but there's going to be different types of worded critical thinking questions that Csec sends on your exam paper. So in this case, let's have a look at the ratio. Now, a sum of money was to be shared among A, B, and C in the ratio 2 to 3 to 5. B received $420 less than C. I think we need to highlight this part here. That's going to be key. And so we are asked to calculate the total sum of money that was shared. We are also asked to calculate the sum of money that C received and the percentage of the total that A received. Now you guys can check out my ratio video that I posted on my channel some time ago. I will pin a link in the description box below, or also pin in the comments. If you guys would like some knowledge on ratio, then I showed you guys a 3-step process that you follow to solve any and every ratio question, regardless of how it's structured. And so step 1 when it comes to ratio problems is always to write down what I refer to as the comparative quantity. So the comparative quantity basically is what the comparative quantities are, the individuals that are involved in the ratio. So here I'm comparing the amount of money that A received compared to the amount of money that B received compared to the amount of money that C received. And whilst I've done that, I'm going to also write down the ratio to which this money was distributed. So it was distributed in the ratio 2 to 3 to 5. All right, so that's step 1. You want to write down the comparative quantities and their individual ratio. Now the next thing that you want to do is to write down what I refer to as the TP. And so your TP is what I refer to as your total proportion. Now with the TP, to get the TP, you're going to simply add up the individual ratios, which is in this case 2 plus 3 plus 5. And so that's going to be equal then to 10. So what this means then is that whatever amount of money is being shared, it has a total of 10 shares or 10 portion or 10 parts. Now this part of the calculation, you do it whether you're going to use it or not, because most times what usually happens is that it ends up helping you to solve whenever they're asking you to find out how much money was shared in total. Now, what I did find when I was reviewing quite a few of my students' paper, the assumption that was made when they read the question, if it is that you read the question, was that $420 was what is being shared. When on the contrary, all right, and when we reread this question, you will realize that $420 was not the amount of money that was being shared, but it is in fact B that got $420 less than C. So the comparison or the information that we know now is in regards to B and C. So we have to focus on this part of the problem. A is not involved in this comparison. And so we know now that B got $420 less than C. Let us observe why that is so. The reason why B got $420 less than C is simply because B got 3 shares and C got 5. So therefore, if we go ahead and we process the difference in shares, so we're going to look at the difference in shares. So difference in shares between B and C is going to be equal to 5 take away 3. So therefore, we now know that B got 2 shares less than C. And if B got 2 shares less than C, then that's the exact reason why B got $420 less than C. So therefore, 2 shares is then equal to 420. Our objective here is to find 1 share. This is direct proportion. Always finding the value of 1 portion. So 1 share is going to be equal then to $420 divided by 2. So that's going to give us a value of 210. So 1 portion is going to be 210. So once we have obtained that 1 portion, usually the rest of the question is pretty straightforward, because as you can see here, we are told to calculate what? The total sum of money that was shared. And so we know that the total proportion is 10, and we know that one of those shares is valued at 210. So we know that the total sum, total sum is equal to 10 multiplied by 210, which works out nicely to be $2,100 that was being shared among A, B, and C. Alright, so that solves that question. Now if we move to part 2 here, they're asking us for the sum of money that C received. Now we already can confirm that C got 5 shares, and we already know that 1 share is 210. So it's very easy to write down that C's share, so C's share is equal to 5 multiplied by 210, which in this case is going to be 1,050. But that's not the only way that we could actually calculate what C got. We could have gotten the value of C, because if the total shares is 10 and C got 5 out of the 10, it is safe to assume that C would have gotten half of the amount of money that was shared. So we could have also gotten that 1,050 by simply dividing the 2,100 by 2, because why 2? Because C got half the proportion. The total proportion is 10, C got 5, so C would have gotten 50% of the money, and 50% is going to be 50 out of 100, which is to divide by 2, and that's going to also give us $1,050. So there's always an extra way of thinking about the question. It's just not one way of getting to your solution then. Alright, so the answer for C here is 1,050, and we know that the total sum of money that was shared is actually 2,100, and we know that 1 share is equal to 210 as well. Alright, now we also looked to part 3 here, where you're told to actually find the percentage of the total, that A received. Now there's 2 ways you can actually get the answer for this. You can actually use the value or the amount of money that A got. So we would have known here naturally that A's share is actually equal to 2 times 210. That's equal to 420. And so therefore we could simply say 420 divided by 2100, and you can times that by 100. You will eventually get that the answer is 20%. Or easier way of looking at this is to simply just take the amount of shares that A got, which is 2, divided by the total share, which is 10, and times it by 100%, and we'd still get a value of 20%. All right, and so there's always multiple ways of getting to your solution, but it depends on how much practicing and knowledge you have on the topic then. All right, so that pretty much takes care of question number 1. Like I said, I could run through this particular question within less than 10 minutes, but I want to use the opportunity to walk you through and revise with you topics that I have done months ago. So hopefully you are enjoying the video so far, and if you have, go ahead and hit that like button and already leave your comments and thoughts in the comment section below. Let's move on then to question number 2. So the questions that you will find at question 2 are usually algebraic or algebra based, right? And so you're going to find a wide variety of questions, such as solving quadratic equations, solving simultaneous equations, factorizing, transposing of the formula. Anything that is related to algebra, you're going to find at question 2 most of the times on your external exams. So like I said, these questions were extrapolated from older past paper. So let's dive right on in and see if you can get an understanding behind what is required. So for question 2A here, for 3 marks, you're told to express D in terms of pi, r, h, and p. Now, let's take a moment to get a comprehensive understanding of what this instruction is saying. When it says express D, that literally means that we want to, I'm going to use an I word here that I use a lot in my class. When they say, or when the question says express D or express the D, right, in terms of, it means that we need to isolate D. So we need to isolate D. Let me just zoom up here. Isolate D. And so the word isolate literally means we need to get the letter D from the equation given to be all by itself on either side, whether it be on the LHS left hand side or the RHS the right hand side. So either way, either side, as long as the D is by itself, no problem. Now at the moment, when we zoom into the equation here, you'll realize that there's a bunch of different things that are connected to D. We have H, we have negative pi, and we have R. All those 3 terms are what's preventing us from getting D to be by itself. Now, also when it says here that we should express in terms of whatever, in this case, they say in terms of pi, r, h, and p, it means that the answer that you're going to provide to the marker, the answer should have pi, not the value of pi, but just the symbol pi, just the letter r, h, and p in the solution. Now I would love to come here and tell you that, hey, it's simple. Cross the P out, put D, cross the D out, put P. But it's not as easy as that. And if you guys would love to have a in-depth understanding of how we change subject of the formula, you should see the thumbnail on the screen here. Check out my change subject of the formula. I believe I have part 1 and part 2. So if you guys want to have a solid understanding of how we change subject in a formula, check that video out. A link will be pinned in the description of the video, or it's pinned in the comments as well. So you can check that out at a time that's convenient to you. So let's get right into it then. Glad we cleared that up. Let's get into the calculation process. So I'm going to go ahead then. I'm going to rewrite, say here, P equal R minus pi D all divided by H. Now the first thing we want to get rid of here is get rid of the denominator. Now some instructors will tell you that you can just put P over 1 and cross multiply. right? I like that method as well. I'm not against it, right? But I also kind of prefer when I stick to how I teach. I like to tell my students that you're going to multiply both sides of the equation by the denominator. So I'm going to go ahead and I'm going to multiply this side by h, and I'm going to go ahead and multiply this side by h as well. So I'm going to put times h here. Now what that does for me is that it allows me to cancel these two h's here, and so I end up with p times h is going to give me ph. So p times h is going to give me ph, and then that's going to be leaving me with r minus pi d. Alright, now remember that the aim is to try to get the d to be by itself. So in this case I have a choice. Now right now I have a negative in front of pi d, so I can choose to carry the negative pi d to my left, that is over here, or I can simply leave the negative pi d there and bring the r over here. Now I usually do not like when my unknown or my subject, which in this case is d, I usually do not like my subject on the right, and I do not like when there's a negative number that is in front of my subject. Remember that the pi is tied or it's connected to the d. So if I move the pi, I have to move the d as well. So in this case, I'm going to implore that you go ahead and transpose the negative pi d over here. All right. And so I'm going to then have you transpose the ph over there. All right. And get it on that side. So then I'm going to end up with then is positive pi d. And that's going to be equal to r take away ph. Remember that the positive ph was transposed. Positive becomes negative when you transpose then. And so finally, I can simply divide both sides by pi. So I can divide here by pi, and I can divide here by pi. So I'm going to end up simply by cancelling the two pi's. D then is going to be equal to r minus ph all divided by pi. All right. Now, for those of you who actually did it the other way, then you would have gotten an answer that says pH minus r divided by negative pi. That also is a correct answer as well. All right. So don't worry about that. Your final answer then is going to be D equal r minus pH divided by pi. Alright, so hopefully you guys got a very good understanding of that. Like I said in this video, the aim and the objective is to not only work out the questions, but to teach you the critical thinking that goes behind the questions. I hope you are enjoying what is it that I am teaching here. Let's move on then to the next question. We are told then that we have 4. Let's rewrite it here. So we're going to have 4 minus 2x over 3, and that's going to be less than or equal to 14. Now this is what we call an inequality or an inequation, right? And an inequation is worked out the same way as how you'd work out a regular equation, right? But with the inequation now, you have to be very mindful of an important factor here, and I'm gonna highlight that once I get to that stage. But for the first part of this problem, remember that we're gonna still stick to that word isolate. Isolate is the key word. So how do we know? A lot of my students sometimes get a little bit confused when they see the word solve or they see the word express in terms of solve, express in terms of all these different wording, these different instructions means one thing. Get that particular letter, which in this case is X, to be all by itself. Now at the moment here, we have 3, we have negative 2, and we have 4 that is connected to the X. Those are the numbers that are connected to the X. In fact, we can simply just write that negative 2/3 and 4 is connected to the X. Now I like to get rid of them one by one. Denominator, then I want to get rid of the constant, then I want to get rid of the coefficient that is attached to X. So in this case here, what I want to do is that I want to start off by going ahead and multiplying throughout by 3. So I want to have, say here, 4, and I'm going to multiply it by 3. sorry guys. So 4 multiplied by 3. Then I'm going to have minus, minus 3 multiplied by 2/3 x. And then I'm going to have less than or equal to 3 multiplied by 14. Alright, and so why did I multiply both sides or multiply throughout by 3? Because I have to keep the equation balanced. I don't want to multiply one of the variables in the equation by 3 and not multiply everything by 3, because I don't want to change the equation. I want to keep the equation the same. But the aim of why I multiplied by 3 was simply to cancel these two 3's right here. So I'll have an equation that looks like this. 4 times 3 is 12. 2 times x is going to be 2x. And then we're going to have less than or equal to 3 times 14 is 42. Alright? So with this now, I can simply focus now a little bit more on the numbers that are connected to x. In this case now I have a choice. Just like before, like I told you when I was up here, I told you that in this case I want to transpose the negative pi d to my left because I want my subject to be positive. Now in this case here, I'm going to keep it negative, and I'm going to show you what happens whenever it is that you do not get your subject to be positive. So in this case, what I'm going to do is then I'm going to go ahead, I'm going to transpose the 12 over here. So by doing that, I'm going to end up then simply with negative 2x, pardon me, is less than or equal to 42 subtract 12. Remember that the sign in front of the 12 is positive and the sign in front of the 2x is negative. So I'm going to transpose positive 12. It's going to become negative 12. So I'm going to end up with negative 2x is less than or equal to 30. Now, here's the trick. What you want to do, guys, is remember that once you're dividing an inequality, well, in fact, once you're dividing or multiplying both sides of an inequality by a negative coefficient, do not forget to reverse the sign. What do I mean? I'm going to go ahead and I'm going to divide here by negative 2x. I'm going to also divide here by negative 2x. Sorry, negative 2, pardon me. I'm going to divide both sides by negative 2 so I can cancel these two 2's out. So I'll end up with x here. But because I just divided both sides of the inequality by a negative number, I'm going to reverse the sign that way. And so I'm going to end up with 30 divided by negative 2 is negative 15. Now, let me know, guys, if you did it the other way. Did you carry the negative 2x to the right and brought the 42 over to the left? Did you get the same answer? Let me know in the comments if you did. Alright, but either ways, ladies and gentlemen, boys and girls, the approach is going to be, the answer is going to be practically the same. Alright, so hopefully you guys got a hang of that. Remember, solving an equation, changing the subject of the formula, all of those means that you need to isolate the variable mathematically, transpose and get rid of anything that is attached to that variable then. So we're going to then move right along to this part of the paper. Okay, all right, so here we go. Now we are looking at part C then. We are going to be factorizing. Now, factorization, I do have 2 videos out on my channel on factorization. When I started my channel, I did 2 videos on factorizing quadratic expressions. You can check those out. Those 2 videos, one explained the theory behind it and the other one did some examples. You can check that out. I also released a video on difference of 2 squares recently, and I also released a video on 8CF method. I did a video on grouping method, but I think it got deleted, so I will need to remake that video and upload it for you here. Now, when it comes to factorization, students, there are 4 factoring techniques that Csec usually attack the students with, and those 4 factoring techniques are the 8CF method, the difference of 2 squares method, the grouping method, and the quadratic factoring method. Now, what I find over the years that I've been teaching with, especially because I'm a crash course type of teacher, I usually teach a 3-year syllabus in less than a year. So I have to move very fast, I have to touch and go. And one of the things that many of my students, or even yourself, struggle with at times is recognizing these expressions. Now in class, when I'm teaching this, a lot of you guys will get it right. But when it comes on the exam, it is the recognition of these questions. You have to have what I refer to as identifiers. Now, when I look at these 3 questions here, for me personally as an experienced teacher, when I look at the first example, I already know that this is called a quadratic expression. So you might ask, Mr. Peart, how do you know, or some of you guys call me Apex, how do you know just by looking at this that it's a quadratic expression? Because a quadratic expression a quadratic expression always has 3 terms, and it always has what is called a square at the front, a square term at the front, or it always involves a square. So that is what I do. That is how I identify the quadratic. Now, of course, you can identify the quadratic, but if you have not practiced a lot of quadratic factoring, then recognizing it is not enough. You still will need to know how to factorize effectively. When I look at example number 2, it sort of gives me the sense of a difference of 2 squares. So I'm going to write difference of 2 squares here. So difference diff of squares. That's what it gives me. And so you might ask then, how do you feel or know that it's a difference of 2 squares? Because a difference of 2 squares usually has a minus sign, and it usually when it has a minus sign, and it usually has a number at the end here that kind of looks like you can raise it to a power of 2 or something like that. So in a second I'll explain that to you shortly. So for now, we're going to call that a difference of 2 squares upon first glance. Now, when I look at example number 3 here, I already right away, it's screaming at me that this is a grouping method. So again, you might ask then, how do you know this is a grouping method? Because grouping method is the only factoring question that has 4 terms. 4 terms. Notice the quadratic has 3, difference of 2 squares have 2, and the grouping has 4. So when it comes to factorization, your practicing of these things have to be really good, right? Because once you can identify them, then you'll be able to work them out. All right, so let's get right into it then. So for 6y squared here, let's write this down here, guys. Let's grab a black ink. Okay, so we have 6y squared here minus 5y minus 4. When it comes to quadratic factoring, what you want to do here is the first thing is to multiply a times c. So with a times c, then what you're going to find here is that it's going to be 6 multiplied by negative 4. And that's going to give us negative 24. Now, what's the aim of getting this negative 24 here? Let's write it better so you don't think it's 9 or something like that. So, negative 24. Now, what we want to do here is that we want to break the negative 24 into smaller pairs of factors. So, we want to break it down. I like to start with 1. So, I know that 1 times 24 will give me 24 or possibly negative 24. I know that 2 times 12 will give me 24. I know that 3 times 8 will give me 24, and I also know that 4 times 6 will give me 24. So all of these pair possibly can give me a product of 24, but only one of the pair can give me the product of 24 and also produce the middle coefficient of negative 5. That's the aim. So I know right away just by looking at 1 and 24 that there's no way that I can add or subtract 1 and 24 to get 5. I also can look at this right away and know that there's no way I can add or subtract 2 to 12 and get 5 or negative 5. And I can also clearly see that there's no way for me to add or subtract 4 from 6 and get 5. So the only possible term in this case here is 3 and 8. So you might ask, how would you get negative 5 using 3 and 8? Be very mindful, guys, that 3 and 8 can give you 5 and it can also give you negative 5 depending on which sign you put where. So in this case here, I'm going to make the 8 negative and I'm going to make the 3 positive. So when I add both of them, I'm going to end up with negative 5 because negative 8 plus 3 is negative 5. Now, just in case you're wondering, because I've had students ask me this question, sir, how will I know which number should carry which sign? Well, the shortcut is this. The sign that is in the middle usually is not usually. The sign that is in the middle is always attached to the largest of those two factors, the largest numbers of those two factors, and then you will figure out the rest of how to get the number you're looking for. Now, I don't want to just take these numbers and throw them down because I want my process of getting to my answer to be easier. So what I want to do is I want to go ahead then and I want to place the 8 beside the 6 and I want to place the 3 beside the 6 and the 8 beside the 4 because I can clearly see that 3 and 6 has a common factor and negative 8 and 4 has a common factor. Now, it doesn't mean that if I place the 8 beside the 6 and the 3 beside the 4, I can't get a common factor. It's just that the factoring might be a little bit tricky in terms of you finding the highest common factor. So we want to make things as easy as possible. So what I want to do here is that I want to put 6y squared here. Then I want to put positive 3y here. Then I'm going to put minus 8y here. I'm going to put minus 4 here. Please note that the expression that I've written down here is exactly the same as the one up here. I've just expanded the middle term into 2 other terms because 3y minus 8y is negative 5y. So it's the same expression then. Proceeding then, I'm going to go ahead and I'm going to place these into groups. So you can see that the grouping technique still plays an important role in quadratic factoring. Now in the first bracket here, you'll recognize that 3 and 6 has a highest common factor of 3. And you'll also recognize here that y squared and y has a common factor, which in this case, the lowest term, the term with the lowest power is actually y. So if I open my bracket here, 3 goes into 6 2 times, y goes into y squared y times, and then 3y goes into itself, or 3y into y, 3y goes 1 time. Close the bracket then. Then I'm going to factorize the second bracket, which in this case, 8 and 4 has a common factor of 4. I'm going to make that negative because the negative is in front of the 8. So negative 4. I'm going to open the bracket here. Negative 4 into negative 8 goes 2 times along with the y. And negative divides into negative. Negative divides into negative gives us a positive. And 4 into 4 goes 1 time. Now, I didn't really need to factorize the second bracket. The moment I recognize that the common factor is negative 4, I know that whatever is over here automatically has to be over here as well. So with that said then, you'll always recognize that that's always the same when it comes to a factorization question. Now you'll recognize that these two terms, 2y plus 1, are common. So I'm going to extrapolate the 2y plus 1 from the expression. And so because those are the common factor, what is left is going to be 3y minus 4. And that is how you factorize a quadratic expression. So apart from the video that I did where I explained multiple examples of this, I find that this particular question highlighted more than one ambiguities that comes from these types of questions. So I hope you enjoyed that one and I hope you got the clarity that you need. Let's move on then to the next question. So we have 2x squared minus 48, and like I said earlier, this is giving what I would refer to as a quadratic difference of two squares. Now I have a confession for you. When I designed the paper, I think I made an error in the typing because what I wanted was a double factoring technique. I wanted the 8CF to be mixed with the difference of two squares. Now, let me bring this question down here. What I wanted was that first, I wanted you all to see that 2 and 48 has a common factor, which in this case here, I'm going to pull the 2 out. I'm going to open the bracket, and then what's going to be left is x squared minus, in this case, 2 into 48 is 24. What I wanted actually was whenever I divide the 2 into this number, it produced a perfect square. It didn't happen that way. So then, naturally, this would be your final answer. Very simple. As you can see, I gave you 3 marks because I made an error in the typing. So just this alone, as you see here on the screen, values only 1 point, pretty much. Now, because we're at the Csec level, if we were doing advanced mathematics, or we were doing, you know, like pushing the expression to a complete factoring, a complete factored answer, we could actually take this an extra step. And I did in fact saw quite a few of my students actually doing this, and it was quite shocking because I've never showed them this technique. So it goes to show that maybe some of you guys are actually doing some practicing that I don't know about. Now, what I did see is that some students, what they did is that they went ahead and they converted the 24 to a third value, or they expressed the 24 as third. So what do we mean by third? 24 can simply be square root, 24 can easily be 6 times 4. Now, bear with me for a second here, guys, and just walk with me through the thought process here. Initially, they would have thought that the question is a difference of two squares. Now, you will notice here that there is no number, or there is not a whole number that you can square to get 24. Right? This number is going to be maybe 4.9, but it's not an exact value. So when it comes to a difference of two squares, what we want to do is that we want to try to express both numbers in the bracket to a power of 2, or we want to express them as perfect squares. We are not able to do that with the 24. So what I did here is that I went ahead to convert this here to the square root of 24, square root of 6 times 4. Right? So the square root of 24 is the same thing as the square root of 6 times 4. Now, if you break this apart, the square root of 6 multiplied by the square root of 4, you will find here that this works out nicely to be 2 root 6. 2 root 6. So 2 root 6 is because the square root of 4 is 2, and we cannot find the exact square root of 6, so we just rewrite it back. So therefore, what we're saying then is that 24 is actually 2 root 6 all squared. It's crazy. 2 root 6 all squared. Alright? So that's another way to look at it. So 2 root 6 all squared is actually 24. And you can check it. When you square 2, you're going to get 4. And when you square the square root of 6, you're going to get 6. So that 6 times 4 is 24. Not sure if you guys grasp that concept, but if you didn't, it's fine. You'll eventually get there. Now, pushing this to a complete, carrying this to the point where it's factorized completely, then we're going to end up with 2, open bracket, plus in one bracket, minus in the other. We're going to have x over here, and we're going to have 2 root 6 over here, and 2 root 6 over here. So we could actually bring that to that point. So any expression can be factorized completely. And I don't put this past CXC. I really don't put it past them. They will give you questions like this, and they will instruct you to factorize it completely. So be sure to let everyone know that the first time you've seen this, you saw it here on my channel then. Alright, so hopefully you guys grasp that concept. Let's move right along to the next question. We're going to end up, say, here with t cubed minus t squared plus t minus 1. And this is clearly a factorization. This is clearly a factorization by grouping. So we're going to go ahead and put this into groups of 2. Oh, pardon me, guys. Whoops, using the incorrect pen. Alright, so here we go. We're going to go ahead and group this put it into groups of 2. All right, so in the first bracket here, you can see that we have two t's, t3, t to the 3 and t to the 2. We always want to take out the t, or take out the variable with the lowest power. So in this case, t squared is the common factor. Open the bracket, t squared into t cube, because there's 3 t's here and I extrapolated 2, only 1 is left in the bracket here. And t squared into t squared will go 1 time. Common factor over here. Evidently, we are not seeing a clear number. So whenever this happens and you're trying to find a common factor, usually the common factor is going to be 1. And so when you divide anything at all by 1 or by the identity value, then you're going to get back the same thing here, which is going to be t minus 1. All right? So then naturally then, we're going to find here that the common factor is in fact t minus 1. So that's t minus 1. And what's going to be left here is t squared plus 1. Now, I like to think like my students. Some of my students may regroup. So if you want to therefore put this t, right? If you want to put this t with t cube and put the t square with the 1, no problem. You can actually do just that. That is perfectly fine. All right? Beautiful, 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 beautiful question then. All right, so we have just passed an hour into the video and we've just pretty much completed question 2. I hope you are enjoying the video. If you have learned a lot, it's okay to take a break and return back to the video, because we will be here for another hour and a half, because I want to ensure that at the end of this video you have a comprehensive understanding of several topics that we will be going through. All right, so I'm going to take a quick break and I'll be right back with the solutions to the rest of the questions on this paper. I'll be right back, guys. So we are getting into the important part of the paper now. Now we're moving towards the graphical applications now, and so we're looking at question 3, and now we are being attacked by the topic of coordinate geometry. Now, like I said, I have a complete tutorial, part 1, 2, and 3 of this topic. It thoroughly explains the concept of graphing, how to plot points, how to draw lines, how to read the Cartesian plane. All that good stuff is available on that tutorial. So be sure, if this is a topic that you've found challenging over the many times you have been doing math, you definitely want to check that video out. Put it down on your list of topics to practice leading up to this external exam, which is scheduled for May the 9th, 2025. But let's dive right on in here. It says, question 3, we are to determine the gradient of a line AB with equation 3x minus 4y equal 7. Now, this question is a question that is not very traditional, because usually whenever a student is required to find the gradient, they are usually provided with the coordinate values, so they can use the whole gradient formula y2 minus y1 over x2 minus x1. Or sometimes you're provided with the graphical drawing where you can use the rise over run formula. So for this question, a few of my students did in fact express that they did not comprehend what is it that the question was asking. So here we go, guys. Now, if we can recall, in part 2 of my video, I did say to you students that the general formula for an equation of a line is y equal mx plus c. So that's the general formula, y equal mx plus c, where m is the gradient. Now notice the position where m is. If m is the gradient and m is in front of the x variable, then usually we can conclude that the number that is in front of x is our gradient. Now, it would be nice for me to just go ahead and say, hey, the gradient is 3, but the equation that is given to us by Csec on this question is that the equation is written in the standard form. So you might ask, what is the standard form? Now, Csec writes an equation in 2 forms: the general form, which is y equal mx plus c, and they also write it in the form ax plus by. They also write on ax plus by plus c equals 0. So this is called the standard form. This is something that I've went through thoroughly in part 2 of my coordinate geometry video. Now, if you notice that in the general form, in order for us to successfully identify the gradient of the line, y must be isolated. There we go again. It is that word isolated, which is why understanding how to change the subject of a formula or change the subject of an equation is critical when it comes to a lot of the topics that are in mathematics. So we're going to go ahead then and dive right on into trying to isolate y from this standard equation given to us here. So we have 3x minus 4y equals 7. What we want to do here is that we want to bring the 3x over to this side. We want to put the 3x right in front of the 7 because x comes in front of the constant c. So I want to put that 3x right in front of the 7. So I'm going to end up with negative 4y, and that's going to be equal to negative 3x plus 7. Now, nothing is wrong if you put the 3x behind the 7, because at the end of the day, our focus is to try to get the y to be by itself. Now, if I go ahead then and isolate the y, I can simply go ahead and divide both sides by 4, or divide throughout by minus 4, pardon me. And then what I'll get when I isolate the y is that y then is equal to negative divided by negative is positive, so that's 3 over 4 x, and positive divided by negative is negative 7 over 4 y. So it's negative 7 over 4. So in this case, now that y is by itself and the equation is now in its general form, we can clearly state that the gradient of this equation is actually equal to positive 3 over 4. Now in this question, they didn't ask you about the y-intercept, but they may switch up the question on you and ask you for the y-intercept instead of the gradient, or they might ask you for both. So in this case, the gradient is 3 over 4, positive, and the y-intercept is negative 7 over 4. In this case, what is the y-intercept? It is the point at which this particular line will cross the y-axis. In another tutorial, we'll dive a little bit deeper into the graphical application of this concept. So, very simple question. It is just a case where your algebra skills have been attacked. Alright, so that takes care of that question. The gradient is 3 over 4. Now, as we move down to this question now, we're looking at the more expected type of question, because this is the type of question that students expect. When I say this is what they expect, usually whenever you're asked to find the gradient or the length or the midpoint or the equation of a line, usually they provide you with the coordinate values like what we have here. So here they're saying that that we are to calculate the length of the line PQ with coordinates -1, 4 and 3, -5. Now, I always label this type of topic in mathematics as a formula-based topic, because if you do not remember the formula for the length of a line, usually you're going to find yourself on the wrong side of the train track, because obviously you need the formula. So let's recall what is the length of the formula. This was discussed in part 2 of my coordinate geometry video. If you haven't checked that video out, guys, please give it a chance. You will thoroughly enjoy that content. So length of a line is therefore equal to the square root of y2 minus y1 all squared plus x2. Oops, I keep writing the formula incorrect. I'm writing y squared. It is supposed to be y sub 2. So it's y2 minus y1 squared plus x2 minus x1. All right, and so you need to be familiar with what is your x2, y2, y1, x2, x1 value. Well, these come naturally from us labeling the points incrementally here. So what we want to do here is we want to go ahead and say this is x1. So this is x1, and this is y1, and this is x2. Sorry, this is x2, right? This is x2, pardon me, and this is y2. So once we have successfully labeled our points, all it takes for us now is to place them in the correct position. So we're going to have, say here, that the length is equal to the square root of y2, as you can see here, is -5, minus y1, which in this case is going to be 4, all squared. And we're going to have plus x2, which in this case is 3, minus x1, which is -1. And we're going to square all of that value there. So now we're going to end up then with the square root of -5 minus 4 is -9. Don't forget to put it in a bracket, guys, right? Because if you write it down like -9 squared, some of you students who sometimes lapse in concentration, when you type that on the calculator, it will give you -81, and that pretty much just destroys all your effort. So what you want to do here is you want to go ahead then and ensure that you put your -9 in a bracket, or what you can do, well, best you put it in a bracket. All right, and that's going to be 3 minus -1, that's going to be 4 squared. So this then works out to be the square root of 81. This works out to be the square root of 81. -9 all squared is 81, and 4 squared is 16. So then this works out to be the root of 97. I don't need to really take it down to a decimal form. I think surds is acceptable. So I'll just say that this is root 97 units. All right, root 97 units. And that brings us our 2 marks that is awarded for that question. We will then proceed to finding out what is the equation of the line. Remember, we stated earlier that the general equation of a line is y equal mx plus c. Let's go to the next page. So we're going to have the equation of a line. Write down the equation of the line. Please remember, let's rewrite our points. P is actually equal to -1, 4. Let's rewrite that over here, -1, 4. And then we have Q, which we stated earlier is 3, -5. 3, -5. 3, -5. And we already labeled this as x1, y1, and we have this as x2 and y2. So therefore then, when it comes to the equation of a line, the equation, or the general equation, is y equal mx plus c. Y equal mx plus c. I did find quite a few of my students using this formula as well, which this formula I'm going to be writing down on the screen, and I'm going to be showing you how to apply it as well. This formula is a formula that I find that most advanced students will use, but I saw more than 5 or 6 of my students using this formula on the exam paper. So if you're that student that prefers that one, then by all means go ahead if you know you are equipped at using it. So it is y minus y1 equal m times x minus x1. All right, none is easier than none. It just really comes down to what you prefer or what you're accustomed to using. So I'm going to show you both of them, and we're going to get the same answer. Now in this case here, in order for us to find the equation of the line, we are going to need the gradient. Now be very mindful that the question that is down here is not related to the one up here. So don't get it confused and go ahead and use 3/4 as your gradient, because as you can see, this question is a part B. It's a different type of coordinate geometry example. So we're going to go ahead then and find the gradient of the line. The gradient of a line when you have the coordinate values is the formula y2 minus y1 over x2 minus x1. All right, x2 minus x1. So labeling the points already, we can see that y2 is negative 5 minus y1 is 4, and that's going to be x2, which is 3 minus x1, which is negative 1. So when we work that out, you'll find that we get negative 9 over 4 as our gradient. All right, now once we have m, we can therefore then choose a pair. We can choose, say here, the pair of values for here. So we can choose either this pair, we can choose this pair as our x and y value, or we can choose this pair as our x and y value. So for this example, I'm just going to use minus 1 and 4 as our x and y value inside here and also right here as well. So therefore then in this case, y is going to be my 4, and that's going to be equal to m, which we just calculated to be 9 over 4. You can turn it into a decimal if you like, if you find it easier, and then reconvert it back to a fraction when you're finished. I find that that's a lot of work, right? Because there are students who kind of prefer working with decimal as opposed to working with fractions. So what you want to do here is just make a decision here. So that's going to be multiplied by x, in this case is negative 1, and that's going to be plus c. Now we're going to go ahead then and we're going to say 4. We're going to have 4 is therefore then equal to negative 9 times 1 is positive 9. Alright, so that's positive 9 over 4 plus c. Now at this stage here, you can go ahead and you can say here multiply throughout by 4, or you can just, for me, I find it very easy if I just go ahead and transpose the 9 over 4 to the left. If I bring this 9 over 4 to the left, I'll end up with 4 minus 9 over 4, and that's going to give me the value of c, which is ultimately what I want. I can put this over 1 here and find the LCM, which in this case is 4. And so 1 into 4 goes 4 times, I times the top by 4. And 4 into 4 goes 1 times, I'll times the top by 1. So 4 times 4 is 16. And 1 times 9 is 9. So I'll end up with 7 over 4 as my C value. Alright? That is if you're taking the fractional approach to the question. Now, if you don't like fractions, you can always use the whole concept of multiplying throughout by the denominator. So in this case, I'll end up with, say here, I can go ahead and multiply the whole equation by 4 at the bottom. So I'll end up with 4 times 4, 4 times 4, and that's going to be equal to 9 over 4 times, well, sorry, I'm going to end up with 4 multiplied by 9 over 4, alright, plus I'll end up then with 4 multiplied by C. Right, so I'll multiply throughout by 4. Now 4 4s is 16, and I already know that these two 4s cancel, so I'm going to end up with 9 plus 4C. Now if I bring the 9 over here, I'll end up with 16 minus 9, and that's equal to 4C. And so I'm going to end up with 7 equal to 4C. And if I divide both sides by 4, you'll find that once again that I end up with C being equal to 7 over 4. So that's another way of looking at it as well, right? So like I said, no matter what you do, you just have to choose an option that you find easier than the other. And if you want to turn that 9 over 4 into a decimal, that's also an option as well. All right, so far we have got the same value for C here. Now like I said, there are some students who are using this whole y minus y1 equal m times x minus x1. I don't teach my C-Sec students this formula, but there are students who are familiar with this based on their experience from their previous year group. So in this case here, I'm going to keep this y here, and then y1, I'm going to use this number over here, 3, negative 5, all right, as my x and y. So I'm going to have y minus, in this case, y1 is, y1 in this case is good. Well, we're going to have y2 here and x2 here in this case. So we're going to have y minus minus 5. And that's going to be equal to negative 9 over 4. Open bracket x minus 3. So y minus minus 5 is equal to y plus 5. And that's going to be equal to negative 9 over 4 times x is going to be equal to negative 9 over 4x. And then we're going to have negative by negative is positive. We're going to have 9 times 3 is going to give us 27 over 4. Alright, so 9 times 3, that's 27 over 4. Now I can go ahead then and I can transpose the 5 that is beside the y. So I'll end up with y equal negative 9 over 4 x plus 27 over 4 minus 5. And you can see I find that this method, especially when the gradient is a fraction, is like you're almost giving yourself more work than you need to. Alright, so I'm going to go ahead and find the LCM, which in this case is 4. 4 into 4 goes 1 time. I'm going to times the top by 1 here. And then we're going to have 1 into 4. 4 times 5 is going to give us 20. So 27 times 1 is 27. And then we're going to end up, say here, with 4 times 5 is 20. So once again, we still end up back with 7 over 4. Let me know in the comments which method you prefer. Alright, and please do not type in the comments, guys, that all the methods are hard, right? Because ultimately you have to choose one that is more suitable for you. But my recommendation is always to choose the y equal mx plus c, depending on your skill level in math. Alright, so therefore in conclusion then, the equation of the line then is going to be y equal, pardon me, in conclusion then, the equation of the line is going to be y equal negative 9 over 4 x plus 7 over 4. And that's the equation of that line that we're looking for. All right. Beautiful, beautiful. Let's move on then now to finding determining the coordinates of m. Please note that this capital M is not the same thing as the M that we were discussing up here. Small m or lowercase m is gradient, capital M is midpoint. So we have to recall the midpoint formula, which is x1 plus x2 over 2, comma, y1 plus y2 over 2. And so we already labeled our points from earlier on, and we said that x1 in this case is negative 1 and x2 is 3. So that's negative 1 plus 3 over 2, comma, y1 is going to be 4 and y2 is negative 5. So that's 4 plus negative 5 over 2. Remember, it says midpoint. So you're going to get a point for your answer. So therefore, then this is going to be equal to negative 1 plus 3 on the calculator is 2. And 2 divided by 2 is 1, comma, 4 plus negative 5 is negative 1. Negative 1 over 2 is negative 0.5. Or you can just simply write negative 1 over 2. And so that is your midpoint coordinate values. That basically tells us the middle or the location to find the middle of that line if we were to put it on the graph. All right, so that pretty much brings us to the end of the coordinate section of this particular video. We're then going to move on to part C. We were going to be closing out question 3. Now, funny enough, ladies and gentlemen, that I've seen questions like what you're seeing here at part C on exam papers. And even though it looks like, you can see it's just 1 mark, many students are unable to grasp or to deliver and collect this, what I would call a free bonus mark or free bonus mark, right? So we're asked to arrange the following in order of ascension. Ascension means we're arranging the numbers from small to large. So in this case, we have a number given to us in percentage, we have a number given to us in fraction, and we have a number here given to us in decimal. It is very, very simple, or it's simpler to visualize a number when it's written in its decimal form. So for 5.2%, percentage is out of 100. So right away I can convert this 5.2% to a decimal. So I can convert that simply by dividing by 100, and I'll end up with 0.052. Alright, to confirm that, move your decimal point 2 places to the back, and then you'll end up with a very clear answer here of 0.052. So I can put a little box around this. That's the first number I have here. Alright, so from there now I can go on my calculator then, and I can use, give me a second here guys, 7 divided by 11, I think it's 0.64. 0.64, give me a second here guys, 0.64. Give me a second here guys, pull up my calculator. So 7 divided by 11, clear this, 7 divided by 11, that's 0.636. 0.64 but 0.636, that's better for me. So so this part here is 0.636636. All right, 0.636. All right, so that part there is clear. Give me a sec. 0.636 636, and then we already have this number. Let's put this in a box here, and then we already have this number that is already 0.125. So what you want to do is that you want to look at these numbers from the end, from the last 3 digits, and see what we're looking at then. Oops, give me a second here. Alright, here we go. Okay, sorry about that guys. So what you want to do is that you want to look at these numbers from the last 3 digits. Okay, 0.125. So what we want to do is that we want to look at 125, 636 and 052, which is 52. So clearly it's evident that 52 is the smallest number. That means 5.2% is the smallest value there. Then you want to look at 636 and 125. 125 is obviously smaller than 636, so therefore 0.125 would be the next smallest value here. And then obviously the last number there is going to be 636, so that means 7/11 is the largest number that is there. So the order of ascension is 5.2%, 0.6, 0.15, and then 7/11 there. Alright, it just popped in my head, ladies and gentlemen, that if you guys are watching this video and you would like access to whatever it is that you're seeing on screen without having to write off everything, I can email you the PDF document. Just hit me in the DMs or in the comments and pin your email, and I will email you the PDF document so you can have access to everything that is on screen here with all the layout. Alright, beautiful. So we are approaching an hour and a half, and we've just completed question 3. We're then going to move into question number 4. Let's take a quick break and we will be right back with question number 4.